Hello and welcome to section 12.2, which is on chords and arcs. A chord is a segment whose endpoints are on a circle. It does not have to go through the center like a diameter would. It can just start on the circle and end on the circle. Theorem 12.4 and its converse state that within a circle or in congruent circles, congruent central angles have congruent arcs, and vice versa, congruent arcs have congruent angles. Theorem 12.5 and its converse, within a circle or in congruent circles, congruent central angles have congruent chords, and vice versa. If you have congruent arcs, they would have congruent chords. Theorem 12.7 and its converse states that within a circle or in congruent circles, chords in equidistant from the center or centers are congruent, and vice versa. If you have congruent chords, they are in equidistant from the center or centers. And there is lots of theorems that go with today's lessons, but we'll be doing quite a few examples together, so we'll show examples of each and it will make more sense. Here's one example that I have for you. What is the value of x? And then you have to justify your answer. And so if you're using the theorems that we just talked about, you can see here that this chord is 36, and if you add up these two 18s, that chord is also 36. And so then if you go back here and read this one again, it says chords that are in equidistant from the center or centers are congruent. And congruent chords that are in equidistant are in equidistant from the center. So these are congruent chords, which means they are in equidistant from the center, which is right here. So if this side is 16, guess what? X has to be 16. And why is that? It's theorem 12.7. Okay, theorem 12.7 proves it. That is my justification. Because congruent chords are in equidistant from the center, and we know they're congruent, so they have to be in equidistant. So it has to be 16. Couple more theorems for you. Theorem 12.8. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. Theorem 12.9. In a circle, if a diameter bisects a chord that is not a diameter, then it's perpendicular to the chord. And theorem 12.10. In a circle, the perpendicular bisector of a chord contains the center of the circle. So they're all very similar to each other. They're all talking about bisecting chords in different ways. So this example goes along with those three theorems. It just says find the value of x to the nearest tenth. And so I've drawn in a right angle right here. And the rate, I guess I didn't mark it, but the center of the circle is right there. Using all of these, it's basically saying, it says here, the perpendicular bisector of a chord contains the center of the circle. So because this is perpendicular right here to the center, okay, we know that it's bisecting the chord. Okay, so we know that this side right here then has to be 8. So we're going to use the Pythagorean theorem because that is a right triangle there in the center. So a squared plus b squared equals c squared. I don't know what, either the a or the b is missing. It doesn't matter which one you put. I'm just going to say that a is missing because remember that this side and this side have to make the right angle. They are the legs. So they are the a and the b. And so since that side has been bisected, we know that it is 8. So since we know that the center of the circle is right here, we also know that this chord, which is the diameter, has also been bisected. And that is your hypotenuse, which is c, so you can put your 10 squared over there. So a squared plus, you can go ahead and work this out, 64 and 100. And then you just go ahead and solve for a like we would normally do. We end up with a squared equals 36. And then we square root to get rid of that square. A equals 6. And I don't have a label there, so just be 6 units. And that would work to find A, which is this side. And it's not marked very well. That X looks like it's pointing to an angle, but it's actually describing that whole side. So bring that knowledge with you, and we'll use those chords or those theorems in many different ways when dealing with circles the next time I see you. Have a good night.